Hello everyone and welcome to another session of Learn Rust with me, Gyan. In this session, or rather in this video, we will be looking at an important programming concept known as looping, which falls under the control flow bracket. You can find this under section 3.5 of the Rust language book that we are referring to. So without further ado, let's first try to understand what looping is, right? So when we think about iteration in any programming language, in any programming context, what it means is instead of writing the same block of code again and again, that is a block of code that we want to reutilize repeatedly multiple times in our business logic, instead of writing it again and again, we use iteration to iterate through that block of code, right? Iteration in programming can be considered of as loops. That is, you loop through a particular piece of code by writing some conditions, by writing some statements, by writing some sort of syntax particular to that language, to ensure that whatever condition you want to perform in the loop, you are able to perform repeatedly multiple times without having to write multiple pieces of code. So if you see the small iteration example, right? When your program block, this code block starts, right? You initialize a particular variable that you want to use for looping, sometimes known as the iterator or the iterating variable. Then you apply a condition for that particular loop to stop. That is, till how far should the loop run? Sometimes your loop could be infinite as well. In that case, your condition will just be if true, right? If something is true, and or whatever condition you would like to write. So the condition would ensure that the loop runs till this particular condition is true. So as you can see, if the condition is true, the body of the loop will execute. The moment the condition becomes false, the loop comes out and it stops, and your code proceeds to the next block of code. This is how your looping statements work. Now let's take a look at the looping statement that is provided by Rust, right? So if you see in Rust, if you're familiar with programming already, there are several different types of looping statements like for loop, while loop, do while loop, etc. In Rust, we have one particular looping statement called loop. We also have another, we also have for loop, but let's start with the loop statement, right? So if you see here, Rust has three kinds of loop as mentioned here: loop, while, and for. So as we go through the code blocks today, we'll try each and every one, right? Let's start with the keyword loop. The loop keyword, as you can see here, tells Rust to execute a block of code over and over again forever or until we explicitly tell it to stop. Here is where the condition that we mentioned earlier, that is the condition to stop the loop, will come into picture. So let's take a look at this code in our Visual Studio Code editor, right? So I'm going to, let me just remove the comments from here, and I'll comment the rest of the code, right? So we just run the first part right now. This is a comment, so I let it be. So as you can see, we are going to be using the keyword loop, and we are just printing again, right? So this basically prints the again statement multiple times unless we explicitly tell it to stop, right? That is, over here we have not given any condition, so it will keep printing the statement again and again and again. So we need to provide an external interrupt through the keyboard to make this stop, right? So let's save this piece of code and see how this runs. So I'm going to say cargo run --bin, and my file name is loops.rs. This is a separate file that I've created for showing you the loops. So as you can see, it keeps on printing run. Now I've given a control C from my keyboard, that is an external interrupt, and now the program has finally interrupted. Otherwise it kept looping and printing this statement. So as you can see, the keyword is loop. You can open braces, give the condition, give the statement to be executed, and we have closed the braces here. Now let's see how we can return a value back from this loop statement, right? So let us see how we can return a value from a loop, right? So here, as you can see in this code block, we are initializing a variable counter, and we are initializing it as a mutable variable. That is the value of this variable. We're telling the compiler that the value of this variable is likely to change through the lifetime of the code. So we'll see here, let's just see this block of code first, and then I'll tell you what is happening here, right? So we write the our keyword loop, open curly braces, and we are saying that this counter will be incremented by 1, right? Now this is a statement that we have given over here. That is, we are telling that this counter needs to be incremented by 1. Fine. Now, if we need to break out of this loop, right, in order to return a result, we need to give a condition that can stop the loop. If we just keep incrementing the counter without giving any stopping condition, it will just keep incrementing, it will never return. So we are saying that when the counter becomes equal to 10, that is, we have used our if keyword to give a condition saying if counter equal to the number 10, then break from this loop, right? Now, once it breaks from this loop, what is the value that the loop returns? It returns counter into 2. That is, when counter becomes equal to 10, the value that returns from this loop is 10 into 2, that is 20, right? So as you see here, the return value of this is captured in another variable known as result. Why is this counter variable mutable here? That is because inside the loop, we are constantly changing the value of this counter, right? We are constantly incrementing the value of this counter. So what this simple loop is doing is that it is starting a particular variable from 0. It is incrementing it up to 10. And when it does reach the value 10, it returns twice the value of the counter at that point in time. So let us run this program and see what this returns. As you can see, the expected result is 20 and the program returns 20, right? So here you can see that the resulting variable from the loop statement can be stored in another variable by declaring a new variable and adding the equal to, similar to any other statement that we define. Same thing, if you remember in the if tutorial, we could also return the value from an if else condition and store it in another variable, right? So let's see some other interesting operations with, okay, so here you can see that we have an example with the while loop, right? So the keyword is simple, it is while, that is while. Now here we have created a variable called while example, and I'm initializing it with the value 5. Since I'll be changing the value of this variable, I'm making it mutable. So the syntax is the keyword while, and then you give the condition for which you want the loop to stop. So here I've said that while the variable while example is not equal to 0, whatever is happening inside the loop can keep happening. So I'm saying that so when I get inside this loop, I can do whatever other operations I want, and then I'm decrementing the value of this variable while example by 1 every time the loop runs, so that it reaches this particular condition that I need. So here what will happen is, so instead of do something, let us actually do something, right? And let us print while example. So what we're doing here is every time the loop runs, we'll be printing the value of this variable. So this variable will start with 5 and then it keeps getting decremented by 1. So you will see 5, 4, 3, 2, 1. The moment the value of the variable reaches 0, this loop will quit and come out, because the while condition says that this variable should never be equal to 0. And once it does reach 0, this loop will exit. So let us run this and see. So as you can see, 5, 4, 3, 2, 1, the expected output is printed. Okay. While is very fairly simple and can be used wherever you have straightforward operations to perform. In any language for that matter, that's where work with while. Now let's move to the next loop. If you're already familiar with other programming languages, for loop is one of the most common loops that is used in a lot of programming languages. So let's see how we can, work with for loop. Let's see a simple example of for loop. Here I am initializing an array called A, and I'm giving 5 elements to it, 10, 20, 30, 40, 50 in this particular array. And I'm going to iterate through the array, right, using for loop, and print each and every value of this array, right, each and every element that is present in this array. So the syntax for loop is for, right, the keyword for, for, and then I define or I declare another variable which will act as my element, or rather, which you can also think about it as an index, right? That is, the element present at that particular index will be stored in this variable, that is element that we have declared here. And then I have to use a keyword called in, right? And then I take the array that is A, and then I apply a function called dot iter. That is, iter is the function. To apply that, I'm using the dot operator. So I say A dot iter, which will iterate through the array and take each element and store it in the element value. So basically what this loop will do is, as it iterates, it will store the value of each of the elements in the element variable, which will be printed at the print statement, right? So there are also other functions that we can use with the array, but right now we're using the iterate function to show an example for the for loop. So let's see how this runs. Okay, so I think I did not comment this while part out, no problem. As you can see, the for loop print output is here. You can see 10, 20, 30, 40, 50. So each element of the array is being printed using the for loop, right? Now there is another way you can also use the for loop to print or rather to perform the different operations inside your loop body. That is by using something called range, right? So we generally say that if you are familiar with other programming languages, we generally iterate the index from a particular range, that is 0 to 10, 0 to length of a particular array or something like that. So in this case, we are having a similar situation here, where I is a particular variable that we have declared here, similar to the element that we declared in this particular above syntax. So we have for I, which will consume the values between 1 to 12, right? So it will consume the values of 1, 2, 3, 4, and so on. So this is the syntax for range. This means that this I will be taking the values between 1 to 12 in an iterative manner, right? So let us print, and then we are printing the value of I, right? So let us print this. So as you can see, 1 to 12. So it takes 1 to n minus 1. That is 1 to the n is your last number in the range. So 12 minus 1, 11. So you can see 1 to 11 is printed as the output for us. Now there is another way to, another syntax for the range as well. So here it is 1, n minus 1, right? 1 less than last, But if you want to include the last, that is 12 as well, then you need to say 1 dot dot. Okay, so here is the syntax which I forgot to mention for range. So the first number, then two dots, followed by the last number will print 1 to n minus 1. But if you want to include that, you can say 1 dot dot and then equal to 12. So this, let me comment this out for better readability. Let me comment the while part out as well and just save this program, right? So as you can see, this is also printed 12 because I have included this with an equal to in the syntax. Now, let me share with you another syntax for defining a for loop. So here you can see, similar to the element or the I part, we have for another variable number in 1 to 4, but we're applying another function called dot rev. So let's see what this prints, right? And then we are printing the number. So basically the guess is what does the dot rev function do? So if you guessed right, then dot rev is nothing but a reverse function. So it reverses this particular range. That is, if you're starting from 1 to 4, but you actually want to start from a reverse range. So here, as we have not included the equal to, it's 1 to 3, that is n minus 1, right? And if you just want to use the reverse indexes, right? Sometimes in the loops, we want to start from the last element instead of the first element. So you can use a dot rev and print this and use this particular variable in your inside your loops, right? So here are some quick examples of the loops. If you want to, so I have taken the examples from the chapter itself. As you can see, the counter example that I mentioned, and then the conditional loops with while, and then okay, all right, so I think this was one of the codes. As you can see, I just did a simple example for while, but you can take a look at the while loop code and see how this is running. Similarly, with for, I use the array. You can also use, so here is a more complex example using a for loop or using while loop, sorry. And similar ones are there for for loop, for element in the iteration, right? And then we have the same in the reverse format. I also showed you a couple of more syntaxes using the range, etc., right? So yeah, that's pretty much it. And as the summary states here, so you have we have finished chapter 3, which was a pretty good chapter when it comes to programming concepts, right? You've learned about variables, the different data types, functions, comments, if expressions, and loops, right? So here are some practice programs which is recommended to practice using the concepts that we have learned so far. So I will be sharing, I will be working on these practice programs and sharing the code with you. So I'll be adding the GitHub link for it in the description box very soon. But I would also encourage you, before you look at the solution, to try these programs yourself using the concepts that you have learned, right? And post this, we have in the next chapter is a very, very interesting concept in Rust that does not commonly exist in other programming languages. And I'm very excited and looking forward to learning that chapter with you folks as well, right? So thank you so much for sort of being with me and learning all these chapters so far. Chapter 3 has been a really interesting chapter, and it has covered a lot of ground for us to start coding right away. So hoping that you're all able to work on the practice programs, and I'm looking forward to interacting with you in the next upcoming chapters as well. Thank you for watching this, and yeah, have a great day.